And this is why I skipped over the table. I skipped over the table because I, in my mind, was like, oh, whatever, I don't really care about the table. Why don't I care about the table? Because I know that if I have k is 2, then I could just shift my original function up 2. So your girl just picked 2, the one that was, I picked the graph that was just shifted up 2. Alright, so think about how you would describe the graph of y equals absolute value of x plus 2. How is that different from the parent y equals absolute value of x, right? And I just said it, right? What happened to it? Did we shift left? Did we shift right? Did we shift up, down? Is it stretched? Is it compressed? What do we think? Nah. Yeah, we just took this graph. We shifted it up how many units? 2. Very good. Sorry, I probably wrote something very detailed. So it's identical in shape. So we didn't scale it or compress it. But we didn't stretch or compress it. But it is identical in shape, but we shifted it vertically up 2 units. That is it. All right, so on 51, there's going to be the summary of information that we have. And I'm going to show you this on the next slide. So I also reference on this next part of page 51, I'm referencing your yellow packet. So you'll see that I wrote some page numbers down next to each one of these transformations. Okay, so this is going to be like, this is it. This is the summary of all the information. You have investigated this information. You've drawn at least 20 absolute value functions here as of right now. If you're translating up or down, a vertical translation, which is just a slide or a shift, you use kind of different words for that, some synonyms for that. But if you're translating things up, you're going to see the plus k on the outside of the absolute value. If you're translating things down, you're going to see a negative k, minus k. Now, the horizontal shift or the horizontal translation is what gets people every time, okay? We said this before, and we're going to see this again. If you're subtracting h, you're moving right. So I want you to like draw an arrow, grab a highlighter, highlight it, do something. Like if you're going to write no notes on the rest of 51, this is the only, if you had to pick one thing to write, it would be write this right now. Because the horizontal translation, you have to translate right h units. If it says x minus h, it's right. If it tells you to shift left, you're going to see plus h inside absolute value. So I put a little arrow. I underlined right and left. This is page 9 in your yellow packet. We only did a few examples of these, though. So I sort of feel like this is easily mixed up. Don't let it happen. Catch yourself. We're also going to talk about these a vertical stretch and a compression. You might think of the word compression. Some people like to call it a shrink, like a shrink and a stretch. I don't know why. But if you look at a vertical stretch, I'm sure there's a good reason. If you look at this a out in front, you have a coefficient in front of the x. We looked at this on page 6. If a is greater than 0 and it becomes a larger number, like 2, 3, 4, 5, 100, 578, 1,261, it doesn't matter. You're going to have this vertical stretching happening. You're going to grab your V shape and it's going to be vertically stretched. Okay? So when you look at that, a vertical stretch is going to result in your V shape being sort of tall and skinny. And a vertical compression or a shrink is when you have the fractional coefficient, like on page 7 of your yellow packet. So if you call it a compression or a shrink, it's fine. Just you have to decide which one you're going to use. I'm just cautioning you now. I'm seeing a couple people that are not 100% writing things down, not 100% keyed in. You're gonna have to do a discussion board, like answer a couple questions. You're gonna have to do some work tomorrow. It's gonna be a lot harder if you don't have this stuff written down. any reflection you see in this course is going to, you'll see the reflection happen because the negative is outside the absolute value. So you're multiplying the absolute value by -1. And sometimes, obviously, you'll have another number in there. So anytime that A value is negative, you're taking the V shape and you're going to reflect it over the x-axis, so it'll end up being an upside-down V shape. And we're not going to see this reflection in the y-axis for absolute value. I'll stick with that. We're not going to see it in the course. It might come up again later, but for another parent, it might come up again for another parent, but it won't come up again for absolute value. So for number 11, just take a few minutes and see if you can fill in an X or a check for number 11. And it says place a check in the box if the statement describes the transformation of the parent function y equals absolute value of x for g of x is equal to -1/3 times the absolute value of x plus 5 plus 2. Okay, so kind of look and see like which one of those values do you think is representing a translation, which one's representing the compression or shrink, which one, where am I translating it? And see which of those boxes you would put a check in, and see which one of those boxes you would put an X in. And we'll go over that momentarily. We have to be able to look at the equation and know that this is g of x equals a x plus h. Yes, I will unfreeze. There we go. Blink. Hopefully stay. Okay, so A tells us about a stretch or compression. Sorry, that's really aggravating. I don't really know what to do about it. I was holding it here, I guess. That's really what I was doing. H tells you about a horizontal shift. And then K tells you about a vertical shift. And then if you have a negative, that means you're going to reflect over the x-axis, right? So let's check and see where you put your x's and your checks. If you don't have the same x's and checks as me, then make sure you get them fixed. So if you have a translation, it says translation right 5 units. I'm sorry, I don't know. There we go. A translation right 5 units means that h is negative. So negative h means you're going right. So I put an x there because your horizontal shift in the original equation up here, the horizontal shift is going to be left. So in that case, my translation left 5 units would have a check with it. Like this. I have a reflection in the x-axis, but I don't have a reflection in the y-axis because we're not going to really look at that. But so you have a negative out here. A is negative, so it's going to be a reflection in over the x-axis. And if it says over the x-axis or in the x-axis, that means the same thing. And we do have a translation up 2 units, and we do have a compression, a shrink, by a factor of 1/3. So this is something that you're going to have to do. Like you're not gonna have the opportunity to make a table every time. You're not going to have an opportunity. If you do try to make a table every time, which is fine, I guess you could do that. I feel like it's just not the best way to tackle the problem because you're looking at a table. You have to do at least like 6 math problems to figure out what's what. So now you're going to have to look at A, H, and K. Okay? The discussion board is on Schoology. I want you to finish it tonight for homework, and I know you don't want to hear that. Okay? But do it tomorrow. Do it tonight. We'll take a look at the results of it tomorrow. Get our minds right. We'll finish the notes tomorrow, and we'll do some practice. And the practice is really where we're going to have the most learning happen. All right? So it's all about the grind of the practice. Let me know if you have questions.